So now let's look at how we're going to work out the angle between two vectors, say vector A and vector B. Now we start off with the dot product, and we have seen it in this form here. So we have the length of A times the length of B times the cos of the angle between is equal to A1 B1 plus A2 B2 plus A3 B3. Now we're going to transpose this for cos theta. So that's going to give us cos theta as A1 B1 plus A2 B2 plus A3 B3 upon the length of A times the length of B. So we know that this thing here is just the dot product, so we can just simply write this as A dot B. So this cos theta is going to be the dot product A dot B upon the length of the vectors multiplied together. So let's go ahead and we'll do an example of this. So let's see if we can find the angle between these two vectors. So we've got vector P, which is 3i plus 2j plus 5k, and vector Q, which is 4i plus j plus 3k. So remember that I, j and k represent the distance along in the x, the y and the z directions. So this is the familiar component form we're used to. P is 3, 2, 5 and Q is 4, 1, 3. So that's just the 3, 2 and the 5 and the 4, the 1 and the 3. So let's go ahead and we'll work out the angle cos theta between these two. So the cos of theta is going to be P dot Q divided by the length of P times the length of Q. So we know we can get P dot Q from the A1 B1 plus A2 B2 plus A3 B3. So it's simply going to be 3 times the 4 plus 2 times the 1 plus 5 times the 3. So that's the top line here. And the bottom line is going to be the length of P times the length of Q. So to get the length, we square each of these terms here and take the root. So it's going to be 3 squared plus 2 squared plus 5 squared. We take the square root and we multiply that with 4 squared plus 1 squared plus the 3 squared. So whenever we add these together, we get 12 plus the 2 plus a 15 all upon the root of 38 times the root of 26. So let's get our calculators out and we'll see what this number is. So this gives us 0.923. So we'll have the cos of theta equals 0.923. So therefore we'll have to take the inverse cos of this to get the angle, and that's going to give us the angle theta is equal to 22.7 degrees. So we'll see a few more variations of this type of problem in the examples video. So thank you for listening, and I'll get you in the next video. Goodbye.